We, the students of GRIT studying 4th year of BTech in Biotechnology, have done our project on understanding the principle and working of HPLC by assaying the drug pantoprazole. HPLC stands for High Performance Liquid Chromatography. Firstly, chromatography is a physical method in which separation of components takes place between two phases, a stationary phase and a mobile phase. Stationary phase is the fixed substance on which adsorption of the sample takes place. It can be a solid, a gel, or a solid-liquid combination. The mobile phase is the liquid or gas which carries the sample through the stationary phase. Chromatography was defined in the early 1900s by the work of the Russian botanist Mikhail Svet. His study focused on separating leaf pigments using a solvent in a column packed with particles. HPLC is a highly improved version of liquid chromatography. In liquid chromatography, a sample consisting of various components is introduced into the column, which includes the stationary phase. Various chemical and physical interactions take place between the sample molecules and the particles of the column. As the sample travels through the stationary phase, the component which has more affinity towards the column travels slower, and the component which has less affinity towards the column travels faster. Since no two components have the same affinity towards the stationary phase, they pass through the column at different rates and the components are separated. The separated components are detected at the end of the column by a detector. The output from the detector is called a chromatogram. HPLC works on the same principle, but the mobile phase is forced through the column by a high pressure delivered by a pump. Therefore, the speed, efficiency, sensitivity, and ease of operation of HPLC is vastly superior. The HPLC instrument consists of a reservoir of mobile phase, a pump, an injector, a separation column oven, a detector, and a data processing unit. The mobile phase in HPLC refers to the solvent being continuously applied to the column. The mobile phase acts as a carrier to the sample solution. The sample solution is injected into the mobile phase stream through the injection port, and the sample solution flows through the column with the help of the mobile phase. The role of the pump is to force the mobile phase through the chromatograph at a specific flow rate, expressed in ml per minute. Normal flow rate in HPLC are in the range of 1 to 2 ml per minute. Typical pumps can reach a pressure of up to 600 to 900 psi. The injector serves to introduce the liquid sample into the flow stream of the mobile phase at a continuous pressure. Sample volumes for manual injection are 5 to 20 microliters, and automatic version is used for large samples. The column is considered the heart of the chromatograph. The column stationary phase separates the sample components of interest using various physical and chemical interactions. It is usually made of stainless steel to withstand high pressure caused by the pump, to move the mobile phase through the column. Other material include PEEK and glass with a diameter ranging from 3 to 5 mm and length ranging from 10 to 30 cm. Column packing is usually silica gel because its shape, surface properties, and pore size give us a good separation. Other material used include alumina or an ion exchange resin. The column oven controls the column temperature. It's a strong determinant of retention time and also affects column selectivity. The detector can detect the individual molecules that elute from the column and convert the data into an electric signal. A detector serves to measure the amount of these molecules. It provides an output to record the results in a liquid chromatogram. The detector is selected based on the analyte or the sample under detection. Commonly used detector in HPLC are ultraviolet, fluorescence, mass spectroscopy, and refractive index detectors. The data processing unit, or the computer, not only controls all the modules of the HPLC instrument, but it also takes the signal from the detector and uses it for qualitative or quantitative analysis. The concentration of each detected component is calculated from the area or the height of the corresponding peak and recorded. Material required for potency assay of pantoprazole sodium using HPLC are volumetric flasks, electric balance, syringe, mortar and pestle, distilled water, 0.45 μm filter paper, 100 ml beakers, and a sonicator. The assay of potency involves the determination of API or active pharmaceutical component in the drug to ensure it matches the label claim. The API should meet the specification limit between 90 to 100% of label claim. Pantoprazole is used to treat the ulcers in the stomach by blocking the production of acid by the stomach. It's white in color and easily soluble in water. Its molecular formula is C16H15F2N3O4S. Its molecular weight is 383.37. The first step of the procedure is to flush the column with methanol for 15 minutes. The second step is to wash the column with distilled water for 15 minutes. The third step is to equilibrate the column with mobile phase consisting of equal parts methanol and buffer till the baseline is stabilized. The fourth step is to inject 20 ml of mobile phase into the system and record the blank. The fifth step is to inject 20 ml of standard pantoprazole into the system and record the blank. The sixth step is to inject 20 ml of sample solution consisting of commercially sold pantoprazole tablets crushed into a fine powder into the system and record the chromatogram. From the blank, standard, and sample chromatograms obtained, we can find the areas of the peaks in the standard and the sample chromatogram and find the potency of the drug. Assay of the drug was found to be 99.05%, which lies between the assay range of 90% to 110%. Therefore, the potency of the drug matches the label claim. HPLC is one of the most widely applied analytical separation techniques. It has the ability to separate, identify, and quantitate the compounds that are present in any sample that can be dissolved in liquid. Today, compounds in trace concentrations as low as parts per trillion may be identified. It is the most important analytical tool in many fields and industries. In the pharmaceutical industry, it is used to verify drug dosages, to determine shelf life of pharmaceutical products, to identify counterfeit drug products, for pharmaceutical quality control. It is used in environmental science to identify phenols in drinking water, to identify antihistamines in sediment samples, biomonitoring of pH pollution in lakes, identify toxins in coastal waters, to identify environmentally relevant bacteria, to identify traces of explosive in agricultural soil. It is used in forensics to identify steroids in urine and sweat, and to determine the amount of illegal drugs in blood. HPLC is used in the food industry to determine the amount of sugar in fruit juices, to analyze the quality of alcoholic beverages, to identify toxic substances such as pesticides in vegetables and fruits, to determine the amount of alcohol in beer, to ensure consistency and quality of soft drinks. We would like to thank HOD ma'am, Principal sir, and Director sir for all their encouragement.